Okay, let's try this next part here. It's a tricky thing for a lot of people. They find it kind of difficult, but it's this sort of interpretation. We're supposed to find the values of x where the product of f times g is going to be positive. And, well, you just look at it and you go, the only way that's going to happen is if f and g are on the same sides of the line. You see, when x is greater than 3, right here greater than 3, f is positive, g is positive. They multiply to equal a number greater than 0. So x greater than 3 looks like it's got to be a place where it's going to work. And so, in fact, that is one of the places. The other place it's going to work is when they're both negative. You see, we're on the same side of the line. X is less than a half, but greater than 0, but not equal to it, you see, because it's not equal to it here. So in between a half and 0, f and g, the line and the parabola, are both negative. And greater than 3, they're both positive. Well, that's the first one. That's the answer. The next one's a little bit tricky for lots of people. We need the derivative of x times g of x to be less than or equal to 0. Well, when is that going to happen? Well, if the derivative is positive and g is negative, then it will multiply to equal a negative number, or 0. Or if the derivative is negative and g is positive, then it'll work. Okay, where is that going to happen? I think it's going to happen between 3/2 and a half. Right here, because you see right here, we know right there, the gradient is negative here, but g is positive, so it works right in between 3.5, and it'll be equal to 0 right at those places there, right, when at a half, so it'll work. So x is less than or equal to 3/2, or greater than or equal to 0. It will make this work. Everywhere else it doesn't work. You've got positive, and then it's gone positive here. The gradient's positive here, and g is positive, just won't work. Here the gradient's negative, and g is negative, so it just won't work. It only works between 3/2 and a half. Now determine the values. When I did this question first, I got it wrong because I didn't read the question. You always read the question carefully. Determine the values of k for which x squared equals 3x plus k has two distinct, I read, roots. And the question is positive roots. Well, how do you do a question like this? Well, here's the function, x squared minus 3x. All you do is take a horizontal line here. Now down here, anything greater than minus 9/4, it will hit two places. I thought that was the answer. But it says two positive roots. That only happens when if k, see, imagine y equals k, y equals 0. It won't be positive. K has got to be bigger than 0. So y equals 0 won't work. Y equals anything bigger than 0. Imagine a horizontal line cutting right across there where y equals a constant. You'll have two positive roots. But down here, you'd have two negative roots, and it wouldn't work. So there's your answer. K is greater than 0.